So we're going to go over the difference between token ring and polling and collision avoidance type of technology, and we'll see how they actually map up and work at the data link layer, and to make sure that there's no corruption or collisions going over whatever type of media, whether it be baseband or broadband, wireless or copper. So you do need to know which protocols work at the different layers. And like at application, there's FTP, SNMTP, or SNMP, SMTP, Telnet. You'll need to know some of the basic protocols. Now at the presentation layer, what protocols work there? At the presentation layer, there's no protocols, there's services that will put the data into the necessary syntax. So at the presentation layer is when the data that comes down from the application layer, it will be put into some type of a standard, which would be Unicode or ASCII or JPEG, and then it goes down to the session layer. So what happens at the session layer? The session layer is when there's a protocol between a client and a server, and that session layer is going to set up and maintain that communication between the client and server, and when the client is done talking to the server, it'll break it down. So at the session layer, that would be NetBIOS, SQL, RPC, NFS, those types of protocols. Then at the transport layer, what's happening there? Well, the transport layer is basically what I said was the bus. It doesn't care what type of data it's moving around. The transport layer provides end-to-end transmission, which just means it will get from the sender to the receiver. And the different protocols that work there, IP, ICMP, the routing protocols. Now, one thing that some people have a hard time with is that SSL working at the transport layer. Because there could be resources that say that SSL works at the session layer, and there could be other resources that say it works at the transport layer. And so I've had people in class get really frustrated because they've learned that SSL works at the session layer. In reality, SSL is made up of two protocols. One works basically at the bottom of the session layer. The other protocol works basically at the higher end of the transport. So it really covers, there's some protocols that actually cover different layers, and that's why neither resource is necessarily incorrect. But another important concept is that this OSI model, when you have layers and you have boxes, it doesn't really exist. It's an abstract way to be able to say how a network stack works. So it's just, it's like trying to put little boxes around life. Life doesn't fit into little boxes, and neither does a network stack. But the OSI model is an attempt to be able to modulize it and break up the different types of functionality. So that's why some protocols, you can see that at different layers and different resources. It's not that they're incorrect, it's just that they cover functionality at both. So for the exam, SSL works at the transport layer. Now networking, what happens at the network layer? Well, that's where addressing takes place. So if when your packet actually comes down and goes to the network layer, it's going to put the source IP address, which is the IP address assigned to your computer. The other thing that takes place at the network layer is networking. So there's networking protocols that we'll talk about. RIP and IPX works there, which is an old Novell protocol. ICMP that we'll talk about today. And then at the data link layer, what happens at the data link layer again? This is where the protocols actually understand the environment you work over. It understands if it's a wireless environment. It understands if it's a token ring or Ethernet. And it has to understand it because it's the last piece, really, that is contributing to your data before it's turned into some type of electricity. So you have a driver. Your driver for your interface, whether it's wireless or Ethernet or a WAN link, your driver will actually work with the network layer and the physical layer. So it'll do its framing, and then it'll do its encoding, which is what type of signal is going to be used. And then it goes down to the physical layer. So what types of protocols would work at the data link layer? Well, I've mentioned some of them already: Ethernet, frame relay, token ring. The other ones are PPP, ARP, L2, TP. These are tunneling protocols that we'll talk about today that are used for actually communicating over some type of telecommunication line and potentially over a WAN link. So you do need to know the different protocols, and they're the ones that you usually see in the industry. They shouldn't have any kind of wild, obscure protocol. It's the basic ones that are used in the industry all of the time. So again, you'll need to understand what devices, when we say that a repeater works at the physical layer, what would that mean if it works at the physical layer? Well, it just means that it's taking the signal, it's taking the electricity, and it's passing it on. It's not reading any header. It's not smart enough or built to actually read any header. So it works at the physical layer, so it doesn't have to have protocols that are at the transport layer and the session layer, because it's not going to process that level of data. So if we say that a bridge works at the data link layer, that'll go up to whatever data link protocol we're working over: token ring, Ethernet, frame, relay. And then the bridge will work at the network layer because it's going to read the network header information to know how to get it to the different place. Now, you could see something that talks about how layers communicate logically, because a computer actually communicates with another computer physically, where there's a physical connection, and it's going to go through the whole encapsulation as I talked about. So there is a physical connection, and that's how communication takes place. But there's also a logical communication. And what a logical communication means is that my presentation layer is going to put the data into a format that your system can understand. My session layer protocol is going to communicate with your session layer protocol. Now, they're not going to communicate directly because they have to go through the whole network stack, get on the line, and go up your network stack. But if you see anything about logical communication, that's because at each computer, the network stack layer, that protocol is writing instructions, the header and trailer, specifically for your system. That's how the transport layer layers will communicate. That's how the network layers will communicate. So that's logical communication versus physical communication. Now we're going to talk about different types of networks. And I do find that people get these confused a little bit between how the network is actually physically structured, which is called the physical topology, versus what happens at the data link layer, which is media access control. So we're going to look at these separately and understand how they work together. Now, the networks can be a LAN, which would be like within a building, maybe 2 buildings. It'd be a smaller environment. A MAN, Metropolitan Area Network, would cover a town or potentially a city. And then a WAN is long distance communication. And now it doesn't have to do just with distance. It has to do with the actual protocol that is working at the data link layer. So LAN networks have specific protocols: token ring, Ethernet, 802.11. MAN has different protocols like FDDI. And then WAN would have totally different protocols that work at the data link layer, which would be frame relay, ATM, x.25. So it's not just the distance of how long, how far the data has to go. It's actually the different type of technology that's used. So we'll go through the simplistic ways that computers can be put together, which is called the physical topologies. And this is just how they're connected. You have, you know, a wire and some devices, and how are they physically put together. So we'll look at a bus, a ring, a star, and a mesh, and how they're different. And you also need to know what they're, if you have a ring set up, what would be a problem with that, or what would be a potential problem that you need to look out for. So we'll talk about some specific issues with these topologies.